Section 4.7, Congruence and Overlapping Triangles. So the whole goal of today's lesson is to identify congruent parts in overlapping triangles. So our first question here asks, what common angle do ACD and ECB share? There are two ways to approach this problem. One way would be to look at the diagram and see where the overlap happens. And from looking at it, I can tell that this angle of ACD is the same vertex as ECB. So angle C is the common angle between the two. Looking at the diagram, let's say you can't picture it well enough, you can also redraw the triangles separately, and you get an idea based on how they're named as to where things are. So just a quick sketch, ACD, then BCE. Well, from this picture, it's evident that C is the common angle. Another way to do this would be to look at the names of the two triangles, ACD, ECB. Angle C is the common angle amongst the two. It's in both namings. So their common angle here is just angle C. Question 1, what is the common side in ABD and triangle DCA? So let's just look at ABD first. So you're going to go from A to B to D. So this is triangle ABD. Then you're going to go D to C to A and back to the start. And at this point, we should have been able to identify that our triangles, when we drew them, overlapped right here at side AD. So the common side would be AD. Then in question 2, what is the common side for ABD and BAC? Well, we've got ABD and then BAC. And we should notice right away that our commonality or our overlap is side BA. Another way to identify the overlap in both problems would have been to merely look at the names again. So notice that there is an A and a D in the name here, and an A and a D in the name here. So AD is the overlap. BAC, ABD, A and B are both in both of these names, so there's your overlap. Here it asks us to identify any common angles or sides. So looking at this particular picture, we should recognize that they're sharing common side JK. Or from just looking at the name, they have J and K in common. In 2, both naming mechanics have the letter D in them, so there's a good chance that the common piece would be angle D. Here it's just asking us to separate the triangles, so we're just practicing redrawing the two triangles separately. So here we'll have N, MP, and then our other triangle, we've got P, Q, and N. And once again, we shouldn't recognize our overlapping pieces. The overlap here is just going to be NP. We'll do the same thing in 4. We'll separate them. Not the best drawing of a triangle, but it'll work. And so once again, we recognize the overlap is going to be angle B. And so now we see the role these play in proofs. So in this proof, they tell us that RT is congruent to US in the given. So let's go ahead and mark that. So RT and US are these long pieces. And this is a little harder to see. So before I mark my diagram, I'm actually going to separate the two triangles just so I can have a better picture of what I'm actually showing is congruent. So we've got U, R, and S, and then R, S, and T. So now back to what it was telling us. It was telling us that RT is congruent to US. So this segment and this segment are congruent. Angle URS and TSR are right angles. So URS is here, TSR is here. And they want us to prove that angle T is congruent to angle U. So right off the bat, we should recognize that this is going to be a CPCT kind of problem. So we'll have a step after we prove the triangle's congruent. But it's nothing we can't solve. So we'll start off by stating the given. So RT is congruent to US, and angle URS is congruent to, or is URS and TRS are right angles. And that's just the given. Now we have options here. We could try to solve this without hypotenuse leg because they gave us right angles, so that's usually a good indicator of hypotenuse leg, but it's not always true. Or we could look at trying something else. Well, I don't know what we're going to use in the end just yet, so let's just go ahead and take the information that they gave us. If two right angles are in both of the triangles, we know they're congruent, so we can go ahead and state that. URS is congruent to TSR by definition of right angle. And so this leaves our options open. We can either go hypotenuse leg or something else after we get more information. Now, if we go back to the diagram, we should be able to see our overlap here. These two triangles were overlapping, and they shared a common side of RS. So we're going to say that side RS is congruent to itself by the reflexive property. All right. So at this point, I'm looking at what I have in my diagram, and so I'm actually stuck with only one option here, because I can't use angle side because that's not a solution method we have. So I'm going to have to go back to hypotenuse leg. I've got two right triangles. I have two right triangles. I have two congruent hypotenuses and two congruent legs. So that's enough to state that these two triangles, triangle USR is congruent to triangle TRS by the hypotenuse leg theorem or HL theorem. And now that I've proven it using the hypotenuse leg theorem, I can now prove that T is congruent to angle U through CPCT, or corresponding parts of congruent triangles are congruent. All right, this time we're given that C is congruent to A, or angle C is congruent to angle A, and segment AB is congruent to angle, or segment CB. So let's just draw the two triangles separately so when we mark the diagram it's easier to see. So right now we've got A, B, E, and D, B, C. So these are our two triangles. Let's mark what they gave us in the given. Well, they're telling us angle A is congruent to angle C, and that AB is congruent to CB. So that's the given. So to start our proof, we'll go ahead and restate the given. From there, we need more information. This isn't enough to prove anything yet. But I know these are overlapping triangles, so if I go back and look at the original diagram, I should recognize that angle B is in both triangles. So what I can do is I can say that angle B is congruent to itself by the reflexive property. And now I have plenty of information to prove these two triangles congruent. I have angle, side, angle. So I can say that triangle ABE is congruent to triangle CBD by angle, side, angle. And in this particular proof, they've given us an extra step because they've asked us to prove that angle BDC is congruent to BEA. So I'm going to be using CPCT in a second. So the last step of my proof is just that statement. Angle BDC is congruent to angle BEA by CPCT, or corresponding parts of congruent triangles are congruent. And remember, to use CPCT, you first have to prove the triangles are congruent, and then your following step will use that reasoning.